Hey guys, alright, so I wanted to get this video out for you. You have an exam tomorrow. Those of you who know me, you have an exam tomorrow, and I hope that studying is going well, and I hope that everything is falling into place. But anyways, I wanted to get a few videos out for you. This one is particularly on specific heat. A lot of people struggle with this, so don't feel bad if you are struggling with it. I hope this video helps. I'm just going to do one example because this example kind of takes a bit of time and thinking. So let's go ahead and jump right into this. So determine the final temperature of the water when a 25.0 gram piece of iron at 85.0 degrees Celsius is placed into 75.0 grams of water at 20 degrees Celsius. So in this, remember what I mentioned before in recitation. For those of you who've had me in recitation, remember what I always like to say is there's three steps that you got to take when you solve problems. The first is to list what you're given. The second is to state what you want to find. And the third is make logical connections to what you're given, right? So make logical connections in the problem. Anyways, so the first thing, let's go ahead and list what we're given. So just write given here. And first of all, what we're given is a an initial temperature. Oh, geez, let me just start from the beginning here. We're given a mass. Bear with me, it's Sunday night and I'm just like, anyways, so a mass of the metal. So M sub iron, I'll denote iron as Fe, equals 25.0 grams. So hopefully you can see that. Get that centered up. Next, we are given an initial temperature, T initial of iron, Fe, equals 85.0 degrees Celsius. And then we're given a mass of the water. So let's go mass of H2O. Actually, you know what? I'm going to say mass sub W for mass of water, and that is 75 point, oops, made a mistake, one line through, 75.0 grams of water. And they also gave us an initial temperature of the water, which equals 20.0 degrees Celsius. What we need to find, we need to find the final temperature, right? So we'll just call that T sub F. And remember, the final temperature of the metal is the same as the final temperature of the water. So that will come in handy later when we go to set up our expression that we need to solve. So we want to solve for T sub F, right? Also recall that the heat gained, so Q gained, equals the negative of Q lost. And what that means is that the heat is going to leave the hot object and go to the cold object. Therefore, there's a negative sign because it's leaving the hot object, the lost, and it's going to the gained, or to the water. So the heat is leaving the metal, going to the water, so the metal side is going to be a negative sign. It's losing energy. The water is gaining energy. There, that's a better way to say it. Sometimes I make no sense. I try to make a lot of sense, but I don't. And for those of you who had me on recitation last Thursday, I didn't make a whole lot of sense. And I'm sorry about that. Anyways, what we're going to do, we're going to use this, right? Because we also, have our equation Q equals MC delta T. Right, your book has specific heats in SH for specific heat. I like to use C because C is standard. So Q equals MC delta T. Rolls right off your tongue. So let's go ahead and set up two expressions. So let's go ahead and write the water side just exactly how have it here. So let's go ahead and do over here Q sub W equals M sub W times C sub W times quantity of T final minus T initial sub W, right? And we also have, we'll just write it up here so we have more room. Q of the iron is going to be a negative sign in front of it because that's the Q lost. So we're losing heat from the iron. And it's going to equal mass of iron. We'll just go ahead and put our negative sign in front of it. Mass of the iron times C of iron, specific heat, times change in temperature, iron, right? So now we can go ahead and set these two expressions equal to each other because of this relationship right here. So that's our logical connection. So we'll go ahead and say, we'll start over here and do mass of water, CW, parenthesis, final minus initial. And this is just all algebra. We haven't done any science yet, right? So minus mass of iron times specific heat of iron, parenthesis T final minus T initial of iron. Right? Okay, so now what we want to do is we want to solve for the T finals, like what we're trying to find right here. And again, this is all algebra. So if you're not good with your algebra skills, then that's something you're going to want to brush up on. I haven't even done any of the science yet. So we're going to go ahead and solve for this, and I might go a little fast because I'm assuming that you've had algebra before. So so hopefully, you know, bear with me, but we're gonna beast mode through this real quick. So here we go. Let's just go ahead and multiply these out. T final minus mass of water, CW, times T initial water equals negative M. People honking their horns out there. Should have shut my door. Oh well, it's okay. Times T final. And now since we have a minus times another minus sign, negative times a negative is a positive, so we're going to have plus. Oh my goodness, shut up, bro. I don't want to hear that. Alright, earlier there was a train while I was recording. I was like, oh, thank you, train, for trolling my night. Specific heat of the iron times the T initial iron. I should get like a face cam so you can see the funny faces I make when I do this stuff. Like, oh, look at his face. Then you wouldn't pay attention to the science of the math, but that's okay. Anyway, so now what we want to do is we want to get these expressions, like with the T finals, on the same side with each other, right? So then we can factor out the T final and have a lovely day. So what I'm going to do, and again, I'm going to do two steps in one. I'm going to move this guy over to this side by adding this term to both sides. And I'm going to move this guy over to this side by, again, adding both terms to both sides, right? So I'm just going to go ahead and do that real quick. So we've got mass of water, C of water, T final, plus mass of iron, C of iron, T final equals mass of water, C of water, T initial water, plus mass of iron, C of iron, T initial of iron, right? Now I want to factor out a T final. T final times quantity, mass of water, C of water, plus C of iron. Oh, whoa, bro. Calm your tits, bro. Calm yourself. Goodness, the camera is going crazy. And also, while that was happening, I was like being silly and I didn't write in my mass term. So no worries, because they're commutative. We know that algebra is commutative. Lovely little fact there. Hope you knew that. I'll just write this. So that's mass of iron, like that. Mass. This video has been hell to get going. This is seriously the third time I've recorded it, and it's probably going to look like crap, but I don't even care. I want to get this out for you guys, and I hope it really helps. So all I did here was I factored out a T final. Great. Hopefully that is common to you guys. You know what I did. I'm just going to rewrite these terms over here real quick. That camera's just like going down like, oh no. He's like, oh, don't worry. Just gonna fall down while you're trying to record. No big deal. NBD, you guys. That's how my camera sounds. You guys can't hear him talking, but I can. Drew's going crazy. That's what grad school does to you. Alright, so T final. We're going to solve for this. I'm going to divide both sides by this term. That's all I'm doing. This is, like I said, this is all algebra. Haven't even done any science yet. So, TIW plus MFE CFE TIFE. Boom, all over. Move this up so you guys can actually see it. You probably haven't seen the last like couple seconds. All I'm doing is I'm dividing this side over. So we're going to have MWCW plus MFE times CFE, right? And wouldn't you know it, boom, that's it. We solved it. We solved for T final. That was what we're trying to find. Now, all you guys have to do, I'm not going to do this because it's very trivial, but this is the science part. All you have to do is plug these numbers in to these variables here. Plug all those in. You know all of this. You know the mass of water. You know the specific heat of water. You know the initial temperature of the water. You know the mass of iron. You know the specific heat of the iron. And you know the initial temperature of the iron. Same with down here. You know all that stuff. You plug it in carefully in your calculator and you hit go equals and you'll get an answer. And your answer should be 22.25 degrees Celsius. Now, let's be careful. Significant figures, you should get 22.3. If I did my sig figs right. I'm sure somebody would have a problem with the way I did them, so, you know. Anyways, it's late, it's Sunday night, and I have to go do some studying of my own because I need to do well in my classes. So I really hope this helped. I hope you guys were able to follow along. And again, just plug these numbers into here, hit go, you'll get your T final, and you've solved your specific heat problem. Now I'm going to email you guys real quick and let you know that videos will be posted. So have a good night, happy studying, and good luck on your exam. I will see you tomorrow. Goodbye.